In the next part of our review of differentiation, we'll go through the product and quotient rules. So first I'll give you sort of the formal statement of those rules. The product rule says if you want to take the derivative of one function f of x times another function g of x, what we do is we take the derivative of the first one times the second one left alone, plus the first function times the derivative of the second function, right? You effectively just take turns with them being derivatives. If you have three functions in here, f, g, and h, you'll have three things here added up, and in each one of them takes the turn being the derivative. So you'll have f prime with g and h, then plus f and h with g prime, and then you'll have f and g with h prime. So you just sort of take turns taking the derivatives, right? So that's the product rule. I'm really hoping you remember that. Next up is the quotient rule. The quotient rule says that if you have the derivative of one function divided by another function, and I actually don't really have this memorized without the verse, so the little rhyme that we have is that it's low, which is g, d high, so g times f prime, minus high, which is f, d low, so the derivative of the bottom, square the bottom, and away we go, or row, or come at me bro, anything that rhymes with low, so that you know that it's low d high minus high d low, square the bottom end, something rhymes with low. Okay, so we've got the product rule, we've got the quotient rules. You either have those memorized, or you've got some mnemonic that you're using to remember them. Let's get to some practice with them. So the first one here, find g prime of x if g of x is this function. Hopefully you see that this is clearly a product rule, one function times another function. You should know how to do both of these derivatives, so pause the video, do this one on your own, sort of make sure that you're getting back into your differentiation groove. So g prime of x equals, so I'll do the derivative of the first thing, and I'm really going to think of this as 4x to the 1/2. So when I take this derivative, I'll bring the 1/2 down. That's going to give me 2x to the negative 1/2 times, I'll leave e to the 2x alone, plus, now I'll leave 4 root x alone, and I'll multiply by the derivative of e to the 2x. Well, remember, the derivative of e to the anything is e to that thing, and then we do the chain rule times the 2 from the derivative of, what was within that expression. Okay, we can certainly do some stuff to pretty this up, and it's worth spending some time on the algebraic manipulation, because you may need to do it for multiple choice questions. So for this first one, you've got 2e to the 2x over the square root of x plus 8 root x e to the 2x. So I would probably be looking at this one as, we can factor out a 2e to the 2x, and that leaves me with 1 over root x plus 4 root x, which is a decent looking answer. Right? So that's my derivative for this one. This was a simple application of the product rule. Next up, I'm asking us to take this derivative. This is clearly the setup for a quotient rule problem. So pause the video, work through this one, and take some time at the end to simplify it and sort of get to the nicest answer that you think you can. So here I have, for this derivative, low d high, remember the derivative of e to the x is e to the x, minus high d low. And you may remember from last year, we actually memorized that the derivative of the square root of x is 1 over 2 root x. You can write it as x to the 1/2 power and bring it down and get a negative 1/2 and move it around. I really feel like it's valuable to just memorize this and just have that in your head. So we know this is 1 over 2 root x. And then square the bottom. So squaring the bottom would give me x down there. Alright, so I now look at this problem and say, yay, I got the derivative, woohoo, but this is a mess, right? In particular, I see a fraction within a fraction here, so I'm going to want to multiply by that to get rid of this. I'll multiply top and bottom both by 2 root x, right? When that 2 root x gets here, I'm going to end up with 2x e to the x. When the 2 root x gets here, it will eliminate with the other 2 root x, so that'll leave me with just minus e to the x. And on the bottom, this is just going to multiply with this to give me 2, x root x. The final thing I would do is that, I really like factoring things, so I would definitely factor this as e to the x on the top times 2x minus 1 all over 2x root x. And I feel like this is probably the simplest, the prettiest, the nicest of the answers you're going to come up with. I've mentioned before, I really don't have a problem with radicals in the denominator. On a multiple choice question, you might have to multiply that up, but I feel like it just ends up looking messier. So this is our answer. We did the quotient rule. So here we have another example of a quotient rule problem. And this one may look a little bit messier. There's a lot of neat stuff you can do to simplify these problems. Occasionally these will show up on the AP exam. I don't know how common they are, but it's a good thing for us to know that we can do in terms of factoring. So if you're feeling bold, try taking this derivative on your own. I'll be walking through it here. I really feel like everybody should be able to do the basic quotient rule. So at least just do the first step of the quotient rule. So this is going to be low d high, so that's 3 times 2x minus 1 squared, chain rule times 2, minus high, 2x minus 1 cubed, times d low, so that's 2x plus 4 to the first. We don't need a chain rule there because the thing inside the x plus 4 had a derivative of 1. And then square the bottom, that gives me x plus 4 squared, so to the fourth. And now we have this thing, right? And some people might start like mega foiling this stuff all together. What actually makes the most sense is to do this with factoring. And the big reason I'm putting this problem here is to remind you of how factoring works, especially sort of on an advanced level. The first thing we can do is we can recognize that all three of these terms, this one, and this one, all have an x plus 4 in them. This one has one of them. This one has two of them, so we can only cancel out one of those. And this one down here is 4, so this will drop down to a third power. Now that I've done that, I can sort of clean this up, right? I'm going to have 3x plus 4 times 2x minus 1 squared. And I just realized that that 3 in the front really should have been a 6 because we had 3 times 2. Minus, we've got our 2 times 2x minus 1 cubed. And this is all over x plus 4 cubed. I really feel like anybody could have gotten, any of you should have been able to get here. It's the next step that's really kind of neat, and sort of helps us to see more clearly how factoring really works, right? Look in the numerator. Don't FOIL this out, but do you see a common factor? Notice that this one over here has a 2x minus 1 squared. And this has a 2x minus 1 cubed. That means these both have two factors of 2x minus 1. So I could factor out that 2x minus 1 squared. And when I do that, what do I have left? The first term just has 6 times x plus 4. In other words, 6x plus 24. The other one has the 2 and one of these 2x minus 1s. So if I distribute that in, I'll end up with negative 4x plus 2. And this is all over x plus 4 cubed. Okay. I'm one step away from being done. I get 2x minus 1 squared times, that's your 6x minus 4 gives me 2x. 24 plus 2 gives me plus 26. And this is all over x plus 4 cubed. And the thing that I love about this answer is that it's so slick, right? I mean, we look at this, we can tell, like, I mean, if remember, this is a derivative. Remember, this is, I forget what we called it. This is like g prime of x. If I were to ask you where this has horizontal tangents, and I know this is a, blast to the past in Calc AB, how do we find horizontal tangents? Horizontal tangents are where the derivative is 0. So where would this fraction be 0? Whenever the numerator is 0. But it's already nicely factored. Like, I can already tell, oh, that's going to happen at 1/2 and at negative 13. Like, you can immediately see those things. If you had stopped up here and I said, oh, where is this equal to 0? We'd all just run screaming from the room. If you had, like, mega super foiled these things together and put them together and you're like, oh, I'll just factor that cubic. There's no hope. Using this method and factoring the numerator works great. And this business is going to happen basically any time you have a binomial to a power over another binomial to a power. Anytime you have something like that happening, this method of simplification can be used. So hopefully that was a fair review of the product rule and the quotient rule. There's a lot more practice to be done. And I hope you'll find yourself remembering this well. See you in class.